Can you believe how quickly we've been filling up this table of contents? We're coming towards the end of our table of contents, and today we're going to use 2 pages. My next 2 are 33 and 34, and today's lesson is called Module 3, Lesson 9, Standard Algorithm, Day 1. So take a moment and fill out your title, M3L9, Standard Algorithm, Day 1. Pause the video if you need to. Our objective today is that you can multiply using the standard algorithm strategy. We've multiplied using area models, we've multiplied using partial products, but today we're going to use our standard algorithm. You've heard these words before. We have a standard algorithm for addition, we have a standard algorithm for subtraction, you'll even have one for division as well. The standard algorithm is typically the most traditional way that people multiply, and sometimes it's the most efficient, meaning it takes the least amount of time, but it does take practice. So we're going to be comparing it to a strategy we already know, which is partial products. The first thing that we do in partial products is that we multiply in our ones place. 5 times 7 ones. 5 times 7 equals 35. Let's compare multiplying our ones using a standard algorithm. Again, I'm going to multiply 5 times 7 ones. The difference is, instead of writing 35 entirely below, I'm going to regroup my 3 tens. I'll leave behind 5 ones. And do you see this box right here? On the line of my multiplication problem, I'm going to regroup my 3 tens. By putting it on the line, it reminds me that I'm going to add it to the next number that I multiply, but we'll get to that step in a moment. Let's go back to our partial product, and this time let's multiply our tens place. 5 times 3 tens. I know that when I'm multiplying in my tens, I need a placeholder 0, so I'm going to put a 0 there. 5 times 3 equals 15, with a 0 at the end, for a total of 150. Let's compare that with multiplying our tens in the standard algorithm. I'm going to multiply 3 times 5 again. 3 times 5 equals 15. But instead of worrying about placeholder zeros, I'm going to go back to this 3 that I regrouped here. Just like I would if I regrouped an addition, I'm going to add this 3 to whatever I've just multiplied. 3 times 5 equals 15, plus 3 more equals 18. I'm going to leave behind the 8 ones, and I'm going to regroup the 1 in my next place value. Before I multiply in my 100s, let's go over and multiply our hundreds place value over here. I know that the hundreds place value has 1, 2 placeholder zeros. Now let's solve the math fact. 5 times 2. 5 times 2 hundreds is 10 hundreds, otherwise known as 1, 2, 3, wee! 1,000. 5 plus 0 is 5. 3 plus 5 plus 0 is 8. 1 plus 0 is 1. 1 plus nothing is 1, for a total of 1,185. Now, so far, we have the same answer, but our strategies have been very different. Let's go back to our standard algorithm and let's multiply in the hundreds again. 2 times 5 is 10. But before I write the number 10, I'm going to add back the 1 that I regrouped. 10 plus 1 more is 11. Since I have no more place values to regroup to, I'm going to put both 1 and 1 together down at the bottom. 1, 2, 3, whee! And look, we have the same answer both times. Let's plug in some rules about partial products versus standard algorithm. In partial products, we stack and add the partial products together. We add the product of our ones, we add the product of our tens, we add the product of our hundreds, and so on until we get our entire product. In standard algorithm, we regroup our partial products. Instead of stacking and adding them all together at the end, we continue to regroup our extra place values to the next place value until we have our entire product. Now, you probably don't feel super comfortable with standard algorithm quite yet, and that's okay. Today is all about practicing it over and over again. So let's go to our second sheet. Let's move away from partial products and let's just practice our standard algorithm. I'm going to start with this problem in the top corner. 8 times 3 equals 24. I'm going to leave behind my 4 ones and regroup my 2 on the line of the next place value. 0 times 3 is 0. Anything times 0 is 0. 0 plus 2 more equals 2. I don't have anything to regroup this time, so I'm going to go over to my next place value. 4 times 3 equals 12. I'm going to leave my 2 here, and since I have no other place values to regroup to, I'll put the entire number 12 down below. 1, 2, 3, whee! Are you getting the hang of it? It's okay if you're not quite there yet, because I have another trick to show you that's up my sleeve. Let's go over to practice 86 times 4. Starting with the math fact, 6 times 4. Again, that's 24. I'm going to leave behind my 4 ones and my number 2. 8 times 4 is 32. 32 plus 2 more equals 34. Here's my trick for you. As you guys move up in place values, you're going to notice that you're going to have multiple numbers on the line that you're regrouping. To keep them straight, after you've added them, I recommend that you cross them out like that. By crossing them out, you're giving yourself a note to let you know, I've used this number, I'm not going to add it again. So every time you finish regrouping and adding a number, cross it out to tell yourself not to add it again. Let's practice this strategy with our next one down here, 23 times 9. 3 times 9 equals 27. Regroup my 2. I haven't used it yet, so I'm going to leave it there without crossing it out. 2 times 9 equals 18. 18 plus 2 more equals 20. Since I have nowhere else to regroup, I'm going to put the entire number 20 down below. Let's do it again with 374 times 7. 4 times 7 equals 28. Leave behind 8 ones, regroup the 2. 7 times 7 equals 49. 49 plus 2 more, 49, 50, 51 is 51. I'm going to regroup my 5. Now that I have more than one number on the line, it's really useful to know that I've already used this 2 and I don't want to get it mixed up with the 5. Now I know whatever I'm going to multiply next, I'll add 5 to that answer instead of the 2. 3 times 7 equals 21. 21 plus 5 more equals 26. 1, 2, 3. Whee! It's okay if you don't feel like an expert yet, because we're going to get a lot of practice and we're going to do this for more than one day. So glue in your notes, take a picture on Seesaw, and let's get going on our problem set.